Iterable. We're here today to talk a little bit about how Iterable built a data pipeline for some internal events, some customer events, and how we did that using Pulsar as kind of the core of the system, S3 and Snowflake sync connectors from StreamNative, some Pulsar functions, and also how we deploy and manage all of it across all of our Pulsar clusters using infrastructure as code in Terraform. First, a little bit about me and the team. I've been with Iterable for about 2.5 years. I started actually as a software engineer on the message queuing team. I'm now the manager of the message queuing team. And our team is responsible for both the Pulsar clusters themselves, as well as writing the libraries that the other service teams at Iterable use to work with Pulsar in the way that they want. So we think of ourselves as a Pulsar platform as a service team for the other teams at Iterable, and we provide all of that, so there's a very low barrier to entry for the other backend teams at Iterable to start using Pulsar. Okay. Here's what we're going to go over today. We're going to just quickly go through what is Iterable in case people aren't familiar with it. We're going to talk about the motivation behind this data pipeline, why we built this thing to begin with, Iterable's Pulsar architecture, as well as the architecture for this specific sync and setup, how we put it all together, and then some theoretical future plans that we have in case those align with any of your future plans. So a little bit about Iterable. Iterable is a customer communication platform, is the way in which we refer to it. We help customers, other large companies, deliver what we call joyful experiences to their customers. So when we talk about in this presentation, customer events, it's not our customer events, it's our customers' events. So some of our biggest customers are companies like SeatGeek and Priceline and Zillow, and the work that they do through our system to unlock all sorts of customer acquisition and customer life cycles, that's the core of Iterable's business. There's a few kind of core products that we have to enable this. The biggest one that we're going to talk about is Journeys, which is our tool for managing, let's call it customer life cycles, from customer acquisition to marketing and transactional communications to those customers. We support a variety of channels and message types and integrations. You can see them all on the screen. At any given moment, we have about 6 billion customer profiles on hand. Again, those are our customers' profiles. And on a normal day, we send between 800 million and 1 billion sends a day for various channels. And all of this is powered by Pulsar. So when we built this data pipeline, when we came up with the way we were going to do this, there were a few kind of key factors that we were looking to solve. The first was we wanted to expand the data observability across the company. There were a few different teams, each kind of doing their own thing around data observability. There was no single cohesive way of gathering all this data together, which was something that was critically important to us being able to grow our business in a good way. The next one was we wanted a scalable way to transfer all this data from Pulsar to our offline data stores that we use. They're not offline in the traditional sense, but not Pulsar. And that's typically Snowflake and Databricks. We use different ones for different things, which we'll get into in a minute. And then the biggest one was we wanted to establish a repeatable process for doing this. So the same way in which we did Pulsar as a service a few years ago for all the other teams at Iterable, this was event pipeline as a service for the other teams at Iterable. So, and then the last bullet point here was we have a customer data sharing program, and this unlocked a whole set of capabilities that we were able to do with that through Snowflake and our customer data share. Just to give you a little bit of an idea about what Pulsar looks like at Iterable, we'll get to the specific data pipeline use cases in a second, but we have 5 Pulsar clusters across multiple regions. We have a bunch in the US and some in our EU data center. They kind of do different things. They're tuned for different use cases that we have for specific reasons. Across all of our Pulsar clusters, we're consuming about 40 billion messages a day. That's not just the data pipeline. The data pipeline is a small part of that, but about 40 billion messages a day. To power the data pipeline, we use a combination of the S3 and Snowflake syncs, SQS sources, and Python Pulsar functions. And all of that works together to form what we call now this data pipeline. At any given moment, there's about 100 sync pods running across all of the clusters, which you'll see later why managing and deploying that through Terraform was so critically important, because otherwise that was way too complicated to do on our own. We use a mix of regex and non-regex consumers, both for the data pipeline and for our overall use cases. And then here's the last important bullet point that'll kind of play into the data pipeline setup. And if you were here last year and you were here for Will's talk, you already know about our topic structure, but just in case, here's a quick review. We have a mix of topics that are both specific to a given customer and general to a thing. So there might be a topic for an event type, but there also might be event topics for customer X, customer Y, et cetera. This is done for a few reasons. The biggest one is so that we can reduce any amount of noisy neighbor concerns between our customers. So if we have thousands of namespaces, each corresponding to one organization, we have the ability to give dedicated resources to each namespace, to each topic, without worrying about interfering with all the other ones. We can also prioritize certain topics. We can prioritize certain namespaces over other namespaces, and it lets us work in a easier to manage way for customers that need either special attention or additional throughput on their topics. Okay, so now we'll get into the architecture of the actual data pipeline for the S3 side, and we'll do Snowflake. We'll do Snowflake next. On the left side is our different types of topics that go to the pipeline. So there are what we call profiles topics, which are just actual individual user profiles. There are event topics, which we're going to focus heavily on the next couple slides. And then we have billing topics and our internal audit log topics for security. All of those topics are all sent to S3 through Pulsar S3 syncs. And then from the S3 buckets are picked up by Snowflake, Databricks, our security tooling, Prisma, we didn't have a logo for it, I don't know. Prisma is one of them, but basically the idea here is that while there are Databricks and Snowflake connectors that we could leverage directly rather than go to S3, we wanted to have this capability that any new use case that wants to come online and use this data, all it has to do is connect to the S3 bucket, which is considerably easier for most tooling than consuming messages from Pulsar directly. We have the security team, just focuses on the audit log, but it all happens to be, through the same kind of sync process. I don't know if you can see from the diagram, some of the syncs are, correspond to multiple topics, like the profiles one. There's only one sync for all the profiles topics. The events each have their own sync, which we'll get into why in a minute. But this sort of flexibility is what allowed us to kind of do what we needed to do to build all this stuff. The event topic specifically is the one that was kind of the most interesting for us to build. When we say events for our customers, we're talking about things like one of their customers opened an email or received an SMS or triggered a webhook by doing some action. And we're tracking 30 different events at the moment for each of our customers' customers. That comes out to about 2.8 billion events per day. The per second throughput of 30K a second is not that much for Pulsar, but because our volume is typically very spiky on the hours for, that's when typically campaigns go out, when journeys are triggered and stuff like that, we end up with peaks as high as 100,000 messages a second, all running through these event topics. And the goal is to get them to S3 relatively quickly. We don't have to get them there in real time, but they do have to get to the S3 through the pipeline in a relatively quick manner. The reason why we configure it with one sync per topic is the events are not even in terms of their throughput and volume. So email open, email send are our two largest by a wide margin compared to some of our smaller event use cases like SMS and some newer ones that we're working on like WhatsApp and stuff like that. It also allows us to configure the actual sync settings slightly differently for each thing. It allows us to change the batch sizing to have a better kind of match in terms of what this event has, what its payload sizes are, what we eventually want to end up in S3. And that's why we have kind of individual syncs for each event type. So that's kind of the overview on the S3 side for the events. The Snowflake one is a little bit more interesting, just because we added some kind of additional components to go along with it. So when we talk about visitor events are things that occur when our customers are in our journeys. So our product for managing customer life cycles, journeys, events are what occurs within those journeys while users are moving through it. For these, we're not typically interested in so much of the full raw data for the data pipeline. We're actually interested in aggregating it together for things like metrics and our SLO and our billing to understand how our customers are using these journeys. So the volume events is way too large for us to put that all into Snowflake if all we're doing is aggregating it. So we came up with the idea that we would sample it and have kind of this 1% sampling of all of those topics, and that's what goes to Snowflake. The trick was we also have what I call the regular consumer service. At this point, yeah. What I call the regular consumer service, which is just another iterable consumer that's not part of the data pipeline but is interested in these topics. And that has to consume 100% of the messages. So the topics have all the messages. Some of our consumers will grab all of them, and others will go through this kind of middle sampling layer situation to then go to a Snowflake sync, which then goes to Snowflake. And Pulsar's flexibility in terms of multiple subscriptions at baseline is kind of what unlocks that capability to begin with. Click. Okay. So the way we do the sampling is there's a Python Pulsar function that sits in the middle. And I recognize that it's not truly random from like a software engineering standpoint. So okay, we'll call it pseudo-random. But basically, we imported just the standard Pulsar function, Python setup. We pseudo-randomly sample at 1%. And then the 1%, 99% of the messages, returns nothing. And 1% of the messages returns the message to a different topic. The way the Pulsar functions work is you specify, the normal things like a tenant and namespace. This is the YAML on the bottom. You specify things like a tenant and namespace where the function's going to live. You name it. You tell it the class. You give it the path to the function that you've uploaded, so it knows what code to run. And this is kind of the secret sauce to it. You specify, in our case, a topics pattern for a regex subscription to the raw topics, and then an output to the sample topic. So all this visitor event data, like we said, the raw topic volume is 13 billion messages a day. So 13 billion messages a day come into the raw topics. Those are consumed at 100% by our other consumers, and at 1% by this sampling function. So we end up with about 130 million a day running through the data pipeline for this particular use case. In this case, we have, through this regex subscription, we're subscribed to over, to thousands of topics, pretty much, all of our customers' topics, thousands of topics. And we're able to make sure that the regex subscription by itself will evenly consume from the topics. So we're never accidentally behind on one customer while being way ahead on another. We're roughly consuming at the same volume. So those are our two pipelines. We have the S3 pipeline, and then we have the Snowflake pipeline to get data from one place to the other. Now, the trick to all this was we have now hundreds of topics, hundreds of syncs, thousands of topics in one case, and we didn't want users to manage this on their own. So we've worked very closely with StreamNative on this one. And we've done a lot of work with the StreamNative Terraform provider to be able to deploy all of this infrastructure through Terraform. The goals here were kind of twofold. One was to make it easy, so that teams that are not necessarily familiar with Pulsar CTL and Pulsar admin and the other command line tools for launching things in Pulsar can do this on their own. The other trick was, from a security standpoint, we didn't want to just be handing out Pulsar credentials to everybody. So all the credentials are stored, by Terraform. Everything is done in the background in our Terraform workspace. We use Terraform Cloud at Iterable just to make it even easier. And the other hard part was we wanted to make sure that each of our clusters had the exact same setup and syncs and topics and everything else. So we started with something simple. All of our Pulsar tenants for all of our clusters. So we have 5 production clusters and 2 kind of staging test clusters. All the tenants for all those clusters are already deployed through Terraform, so we kind of had a basic workflow just for doing tenants. And then we started kind of expanding outwards and started adding the S3 syncs and the Snowflake syncs and the functions themselves and the sources. And now every single part of that infrastructure is deployed end-to-end through Terraform. When we add a new cluster, it's actually very simple. We just copy the provider block, put the new URL in for the new cluster, and everything just gets deployed to the new cluster automatically. We don't have to actually go in and confirm, are the tenants there? Did someone remember to run this script that launches the clusters and stuff like that? And then finally, just from a company compliance and security standpoint, we include open policy agent checks in our Terraform lifecycle at Iterable. That's a standard within all of our Terraform runs. So if we did want to have open policy agent checks added to this Terraform as well, in terms of, you can't accidentally delete a sync, you can't, accidentally give it too many resources that it overwhelms the cluster, stuff like that. All of that can be included as part of our lifecycle. I know it's kind of hard to read. I'll just kind of walk through what the code is, but basically what we tried to do was the StreamNative provider takes a lot of attributes. There's a lot of configuration that needs to be set, most of which doesn't change from sync to sync. So for our 30 event syncs, let's say, the only thing that's changing is the topic it's subscribed to and the prefix that we want to use in S3. The other, 40 data points that the module has are all the same always. So we built our own internally versioned modules that rely on the StreamNative provider as kind of the upstream module for these. And it basically abstracts away everything that our users don't care about or don't need to know about or never need to change. So for the S3 provider, where we use the IAM roles for authentication for S3, we don't expect our users to know what that role is, care what that role is, know how to set the different ACLs in the account and all that kind of stuff. All of that is handled automatically by our version of the module, and all they have to do is provide simple things like what's the name of the bucket, what's the topic that we're subscribing to, and stuff like that. In this particular one for events, because some of them are the same, but some of them oftentimes require more throughput, more resources, stuff like that. So we use this kind of map strategy up here, where each event is defined in the map. Sometimes there are overrides for things like parallelism, for things like the CPU. And then in the module itself, it will either take the value from the map, like each.value.parallelism, or it will use the default of 1, which will only launch one pod. For some of our events, we have as many as, I want to say 8. Most of them run fine on just 1. Some of our busier events need considerably more resources behind them in order to keep pace with the backlog. And then on the last part, on the bottom there, Terraform loops through to build the input specs, which the sync then uses to figure out which topics it's subscribing to. In this case, because each sync is one event, it's not a regex pattern, but it's exactly one topic that this sync is subscribing to. So this is the S3 setup. The Snowflake one is similar. And remember, the Snowflake one is reading from the sample topic, not from the raw topics. So obviously the fields are a little different. There's no role-based authentication for Snowflake. It's not an I'm authenticated service. So instead, we need to store a private key somewhere to allow this sync to work. We definitely don't want to be just sending this private key around. So we use a sensitive TFR in the workspace to hold that Snowflake private key. And then in this particular instance, again, we're subscribed to one topic on the bottom that is the sampled output topic. And that's how the Terraform for the Snowflake one works. We've tried to set it up in a way that users with certainly not people on our team. The goal was to make it so that people on the queuing team did not have to be involved in this as new events are added. Alham from our analytics team is actually sitting in the back. She can attest to the fact that she can do it all by herself, and she doesn't need to involve our team in adding new events. So we started with 30. I think there's actually already like 35 in the last couple weeks. There'll be 50, 100, whatever it is, and all they have to do is just keep copying and pasting the little event block that says what's the name of the event, what topic is it, and then it gets deployed to all of our clusters in the same way. So no one is ever doing this manually. No one is ever passing around credentials. It's all done in a repeatable, safe, and secure way. In terms of things like observability, like what we can do with this. So for one, at Iterable, we use Datadog. StreamNative's Datadog integration is actually quite great. They have the Datadog agent running on our clusters. It pushes the metrics into Datadog, the specific metrics that we want, which makes it, again, very easy to handle, easy to manage. And there's two different kind of types of metrics that we're looking at, just because there's kind of two different types of syncs in the data pipeline. For the S3 one, for the events, we have, this is by topic, so that's why there's kind of different color bars, different events, different topics. And you can see throughout the day, there's some backlog for each message, but it's running through very quickly. We're not expecting the backlog to ever be at zero, but if we see that the backlog is continuing to climb and not at some point, within a few minutes, kind of turning the corner, and going back down, we know that there's likely a problem with that particular event or that particular sync, and then we can provision more pods or more resources for that particular one just to kind of target that one. So whichever one I don't know exactly which one the light blue one is on this chart, but whatever that one was, had, as it kind of comes up towards the hour, it does kind of spike in volume. It's likely one of the big email ones that goes out on the hour. And then we have enough pods running behind it to kind of make sure that backlog is consumed fairly quickly. And then on the right side of the screen, this is how we confirm that we're getting about 1% on the sample topic. So the top chart is the raw topics, and I know it's kind of hard to see the scale, but on the very left side of that, it's around 100,000 on the raw topic, and then 1,000 on the sampled topic below it. And you can see the line is roughly about the same shape for the same time period. And that's how we confirm that we're sticking with that 1% benchmark that we wanted. I don't have a slide for it here. There's no screenshot of it. But we also have alerting configured through Datadog if we're too far on a backlog, if we're too far behind, if the syncs themselves are not running. For whatever reason, there's some problem with the stateful sets or the function mesh or some other issue with our cluster that's preventing the syncs from starting properly. We have alerting around that through Datadog as well. And this is how we kind of keep track of everything and make sure that we're doing everything that we can to make sure the data is getting where it needs to get to. And then finally, just to give you an idea of the future plans for Iterable, which is more about what StreamNative features unlock for us in the future, if any of you are doing anything like this. The first is that we can onboard additional use cases in the pipeline without having to do a lot of work. Adding new events is easy. We already have that. Adding a totally different type is not that much harder, which is great and exactly what we wanted to get to with this thing. The middle bullet's the cool one. We don't have it turned on our clusters yet because I think StreamNative was still testing something for us, but to have sync and function auto-scaling enabled to scale horizontally based on the backlogs. Right now we have to manually go in and add replicas if we're behind, but to be able to set a threshold of backlog for a given topic or a given subscription, and then have pods brought up automatically would be very great for us. And then the last one, and this is something we're playing around with already, but just not production ready yet, is using StreamNative's Pulsar function SQL to add a more kind of dynamic layer to this whole thing, where we can conditionally consume messages, certain messages through the pipeline. So rather than have something like a dedicated topic for each event, we could have single topics for all the events, and then only grab the type of event off that topic that we wanted. And that would kind of make our life a little bit easier as well. And that's these are kind of our future growth plans for the data pipeline. The last one, there's no bullet for it, but the last one is in theory to support, we were saying like everything goes to that S3 bucket. Anything new that comes online, any new data tooling that the company wants to use, anything that can be backed by an S3 bucket, we can immediately support. And that's considerably easier than trying to get teams to stream data right out of Pulsar. I think there's a lot more that teams would have to do to get to that point, whereas this is a relatively attainable, oh, sure, we can connect to S3, like no big deal. And that's it. So I'm happy to take any questions. There's a bunch of people in Iterable shirts around. You can also ask them questions throughout the day. There is a prize. If you do ask questions, you get a little giveaway token thing, and then you can redeem it for swag at the swag stand. So there's like a cool incentive to ask questions. So even if you don't have a great question, just ask one anyways, and you get a shirt. Be like, you can ask me like about Iterable, about my life, whatever you want.
Quick question.
Yeah.
When you publish to the Pulsar topic, do you use Kafka APIs or something else?
We use so our whole back end is in Scala, and there's like a Pulsar 4S like Scala client wrapper, and that's what we use to publish into the topics from everywhere. If that's what you meant.
Right, because you showed a bunch of topics, then they go to S3.
Right.
And S3 seems to be your choice for consumption.
Yes.
Have you ever considered using like a Kafka plus Flink to do those things?
Yes, that could be one of our backend engineers is turning around like, see, I told you they were gonna. Yeah, so that's definitely on the like kind of roadmap. This was more of we're already using Pulsar, we're already using Snowflake and Databricks and these other tools. How can we kind of put those together in a kind of easy manner? And this was the easiest way. There's definitely like a pilot program in the company to look at Flink and more traditional data streaming. Like I would say this is like data streaming adjacent at best. But yeah, that's definitely on the roadmap. It's just not, it was a little bit harder to get started on that. Whereas this was kind of we already had all these pieces together and we just had to put them together.
And then the final follow on to that is the end-to-end latency.
Yeah.
Right? Since you go through an S3 bucket, and is latency a concern for you at all?
No. So it happens to be that they're running like an import job from the S3 buckets into Snowflake not that often, but if they were running it in real time, we actually did measure it. We're getting messages from Pulsar into Snowflake about 20 seconds total from like end to end. Every 10 seconds or so, we're sending another 50,000 events to the S3 bucket, and from there they get picked up basically right away by Snowflake. So it's pretty quick.
Hi, I think you touched upon this where you're saying you want one stream for all topic, or like all events go to one stream versus each being separate. Like what's the idea behind that?
So the goal would be that we can different data platforms in the company, maybe, or different even regular iterable consumers might be interested in only certain event types. So there might be a situation where we're tracking all 30 of these events, but there's some tool that really only wants to know about one type. Right now, we don't have a good way to do that. We kind of have to park each event on each topic. But the idea that we're kind of playing with is that if we start using things like the message properties or even a part of the message payload to indicate what type of event this is, we can conditionally consume those messages without having to consume all of them and then ignore 2/3 of them or something like that.
So it evolved like that, or was that the original design?
That is not the original design. That's more of an optimization now that we've built this to say, oh, what else could we do with this? If there's specific events in here that you're worried about, we can grab those events instead of having to kind of read through many events just to get to the ones we want. So it's not so much even event type. It could be targeted more to like a specific customer's events, a specific time frame of events. There's all sorts of kind of like targeting we could do if we had that capability to kind of search through the messages using the Pulsar function SQL.
So it seems like you'll need a whole release cycle, just because if you're creating a new event type, you need all your pieces to work together to not just send the data, but also digest that data.
Yeah, so normally what happens is like some of the backend teams will work on the event itself actually existing in the iterable ecosystem. And then once that's all done, they will add a tiny block in Terraform that enables the sync code for that event, for that topic. And then that's the very last piece that they do.
I have a quick question about the underlying data structure, underlying data technologies. Talking about Snowflake and Databricks multiply. Any particular reasons for this sort of streaming application you chose those platforms for this?
Elham, you want to take the mic and answer that one? Elham's a member of our analytics team. Her team is the one who uses this a lot more than we do. My team kind of just gets it to S3. So I'll let the data team take this one as a guest star speaker.
Sure, I try my best. So for the Databricks one, we are using it for some AI features that we are doing. And Snowflake is, we have this option that the customer can get access to all of their data via Snowflake. Because of the customer need, we go with the Snowflake as of now. Yeah.
We're in BigQuery today for most of that sort of data lake technology.
Yeah, sure. So right, it was. I wasn't sure, I guess, on the why, but it was basically different use cases. So that's why we kind of centralized to S3. Both of them can pull from the S3 if they want it, but then we're not really limiting. We tried first to say, well, we can push directly to Snowflake, we can push directly to Databricks. But the problem with both of those options is that then we're doing it twice effectively from the Pulsar side, and we really didn't want to. So our goal is we get everything to S3. Any team in the company that wants this can connect to the bucket and consume from the bucket. There's like a 2-day life cycle and versioning enabled on the bucket. So there's time. It doesn't have to be like that quick. But if even if a team wants to write a random Python script that pulls from the bucket to look at the events, they can do that if they want. And it's a fairly low barrier to entry for the other teams because all they need is access to S3. Thanks, Elham, for guest covering that question. Any other questions, comments, ideas? Doesn't have to be about this. Could be about me, or Iterable in general. You get a T-shirt, so I'm really selling these shirts hard.
So just out of curiosity, was it your first or second slide showed 6 billion customers?
Mm-hmm. Yeah.
So given that there are 9 billion humans.
Good question. Yes, we don't dedupe them. Yes, correct.
But I was wondering. So of the human population, how does this cover 10% or what?
Our biggest customer probably has 300 million profiles on hand for us.
Okay.
More? 800 million profiles on hand for one of our customers. I'm a little behind, I guess, the scale curve. So, yeah, no, that's right. That is, we certainly don't have profiles for almost every person in the world. If you're a customer of SeatGeek and Priceline, you have 2 profiles in our system, one for each customer. They also have We didn't really touch on this at all, but Iterable is kind of a customer data platform. Each of our customers can define different fields and for those profiles. So SeatGeek's profile is dramatically different than Priceline's profile. Yeah. So I'm a similar customer, but on this one I have that I like the Detroit Lions, and on this one I have like flights that I've taken and stuff like that. So there's not a lot of commonality between the profiles anyways.
And there's still plenty of room to scale up, in other words.
Plenty of room. So when I started I've been in Iterable 2.5 years, we were doing probably 400 million, we're probably about half the send volume per day as we are right now, and considerably less. We said it was 40 billion a day consumed. It was probably about half of that when I started. And as we onboard new use cases, and we didn't touch on this at all, but we went away from RabbitMQ when we started using Pulsar, just because RabbitMQ could not keep up with that load. And we've been using Pulsar now at Iterable for 5 years, I think, total. And we would not have been able to get to this level of volume without it. It's like absolutely critical to our business running. Yeah. Okay. If there's no other questions, I guess, again, I'm around all day. There's other people with Iterable shirts on, say Iterable right here. So if you have other questions about Iterable, what we're doing, if you're interested in joining Iterable, please come and talk to us. We'd love to meet you guys and kind of see what other people are doing with Pulsar. And enjoy the rest of the day.